All right, in this movie we're going to talk about the binary system. We're continuing our theme on different numbering systems. If you did not already watch the video on the decimal system, you should really watch that. The decimal system is very easy for us, but you need to be able to think of numbers in a certain way, and then other numbering systems will hopefully be easier. The decimal system, remember, deci meant 10, so it was a base 10 type system. This is called the binary system. BI stands for 2. So this is a base 2 system, which means we're going to have things like 2 to the 0 and 2 to the first, and basically 2 to the x power. And so if it's a base 2 system, then that means there are only 2 digits that we are going to use. If you remember, in the decimal system, it was base 10. There were 10 digits we were going to use, 0 up to 9. We always start our digits with 0. So if there's only 2 digits that we can ever possibly use in this system, and by the way, you would think that that would make this easy, but it's still not easy for people, then we start with 0. And then our next digit is 1, and that's it. There's only 2 digits. We can only have 0 or 1. So there's only a 2-digit system, or a binary. These would be called binary digits, because there's only 2 that we could possibly use. And if you take the B here and the it on the end, we call these little 0 or the 1, we call them bits. So a 0 is a bit, a 1 is a bit. And we can make numbers out of these and hopefully be able to read binary numbers to see what they are as decimal type numbers. So, and by the way, when we're talking about binary system, there's only 2 possibilities, a 0 or a 1, and a lot of times what this means is we refer to this as on or off. So like a 1 means that it's true, and a 0 means it's false, or a 1 means it's on, and a 0 means it's off. And you've actually seen these symbols in a lot of different places. Like even if you look on the back of your computer or back of some device, a lot of times you'll see like a switch. An on-off switch is what I'm trying to say. On-off switch, and you'll see that on one of them there's this, and the other one there's this. It's an on-off switch. Well, those are binary digits. The 1 means if you're going to push that, it's going to turn it on. If you push the 0, it's going to turn it off. Or on your computer, if you look at your power button, or any kind of power button on most things, what is it? Well, it looks like this, right? Well, that's a 0 and that's a 1. So that's an on-off switch. It's a power button. So the reason that we have to even understand the binary system is because this is how computers work. They work with binary numbers, ons and offs, ones and zeros. And so when you type in like a letter A on your computer screen, that's not actually what's going into the computer. There's a binary representation of that letter A, and it's good in computer science that you know the binary system and know what characters and things are represented by what binary numbers on a computer. Okay, so let's figure out how to read a binary type number. And remember, in the decimal system, I did something like 5,097 or whatever, and that was really easy for you to know what that number meant. But a binary number would look quite different. Let's say we have a 1, 0, 0, 1. Let's say we have this number here, a binary number, and I want to know what is this binary number. Well, this is exactly like the decimal system. This first place here in the decimal system, of course, was 10 to the 0. But now we have a different base system. So this digit here is going to be into the 2 to the 0 position. This next digit is going to be into the 2 to the 1 position. The next digit is going to be into the 2 to the 2 position. The next digit is going to be in the 2 to the 3 position, and we could keep going, so on and so on and so on. In fact, maybe we should. Let's do 4 more. Let's do those. Okay. So what do I have here? This is in the 2 to the 4th position. This is the 2 to the 5th position. This is the 2 to the 6th position. This is the 2 to the 7th position. And the reason I did this is because if you remember up here, each 0 and 1 is called a bit of information. A bit. They're binary digits or bits. So this is a bit. This is a bit. This is a bit. If you have 4 bits in a row, 4 bits. We started playing with names here, so 4 bits is actually called a nibble. 4 bits in a row is called a nibble. And if you have 2 nibbles, or how many bits? 8 bits. 8 bits. 8 bits of information is called 1 byte. And you might have heard that before. 1 byte, B-Y-T-E. So 8 bits is 1 byte. So this is a byte of information here that we have. And I want to know... that's a binary number right there. Well, what is that number? I mean, what is that number in decimal forms? Like if I wanted to be able to say, that it's a real number that in what I understand, I want to convert this to decimal form. How do I do that? Well, just remember how we did decimal systems. You took your first digit times 10 to the 0, or base times 0, and then you took your next digit times base times 1, base to the first power, and you took your next digit times base to the second power, and you added them all up. So I can do the same thing here. Instead of grouping by 10s, we're grouping by 2s. That's the only difference here. And it's crazy that that's the only difference, but this becomes so difficult for students to understand. It's why you need to have a really good grasp of your decimal system and the way you actually think, the way we should be thinking of numbers. So what is this number? Well, let's go ahead and do these out here. 2 to the 0 is actually 1, because a lot of times people don't like to think about the base to the power. They like to just think about what place this is. And in a regular number, and like I had 693, this is called this is the ones place, the tens place, and the 100s place, right? So what places do we have in binary? Well, the first place is always the ones place, because anything 2 to the 0 is 1. 2 to the first is 2. So this is actually called the 2's place. 2 to the 2 is 4. That's the 4's place. 2 to the 3 is 8. That's the 8's place. And you'll notice that all we're doing here is multiplying by 2 each time. So that's an easier way to think of it. So my place values in a binary number is 1, 2, 4, 8, 16, 32, 64, 128. So those are the place values that I have in a binary number. So all you need to do is, just like a decimal system, take the digit you have in that place and multiply it by the place value. So over here in this decimal system, I had a 3 here, a digit 3. Well, I take the 3 times 1, and that's 3, right? Then I have a 9 in the 10 spot, so I take 9 times 10, and that's 90. And then I have a 6 in the 100 spot, so 6 times 100 is 600, and my decimal number is 693. So I do the same thing here with the binary system. In the ones spot, I have a 1. So I take 1 times 1, and I take 1 times 1, and I get 1. In the 2 spot, I have a 0. So 0 times 2 is 0. So you don't have to worry about anything in the zeros positions. It's nice and easy. Basically, we don't have those positions turned on. They're turned off. But the positions that we have turned on, we need to account for. So I have a 1 in the 1 spot, so I have 1. I have the 8 spot is turned on, so 8. I have the 16 spot turned on, so 16. I have the 32 spot turned on, 32, and I have the 128 spot turned on. So I can add those all up, 16, 6, 22, 23, 24, 25, 5, carry the 2, 5, 6, 7, 8, 85, 185. So this byte of information is the number 185 if I've converted it to the a decimal type number. 185. So that's how you convert binary numbers to decimal type systems. Let's see. Let's do some problems then. So what is the biggest decimal number I could get out of a byte of information? A byte would be 8 bits. The biggest number I could get. Well, that would be 1, 2, 3, 4. 1, 2, 3, 4. That'd be a byte of information, and every single bit is turned on, right? They'd all be 1. So what do I have? Well, I have let's see. Let's do this. Let's do it this way. So I have the 1's position, the 2's position, the 4, the 8, the 16, the 32, the 64, and the 128. And so here's my binary number. I'll spread it out here. I got 8 bits, 1 byte of information, and every bit is turned on. So what would that be? Well, the 1 is turned on, the 2 is turned on, the 4 is turned on, the 8 is turned on. Every single one of these numbers is turned on, and so I would add them all up. And if you add all of those up, the biggest number you can get with a byte of information is 255. Now I do that one because that's really important. That number is significant and comes up in a lot of different places you're going to see later. So I just wanted you to remember that with a byte of information, you could get the highest decimal number you could get would be 255. What if I did one more 1 out here? Well, all of these then, if I added 1 onto this, I would get 256. So that would put a 1 here, and that would make all the rest of these zeros, right? Because what's the next number after 128? Right? You're going to take that times 2, and you're going to get 256. So the next position here would be the 256 position. That'd be 1, and then all these rest of these would be 0, and you'd have 1 in the 256 spot. So if I added 1, so if I did 1, 1, 1, 1, 1, 1, 1, 1, that's 255. If I added 1 to that binary number, then I would have 1, 0, 0, 0, 0, 0, 0, 0, 0. So I have a 1 and then out of the 256 spot. I don't know if that makes sense or not. I hope it does. Let's work backwards. Let's take a decimal number and try to write it in binary. Let's take let's just do number 22. Okay, and we're going to try to write that in binary. So what I do is I write out my positions. I start with 1, and then 2, and then 4, and then 8, and then 16, and then 32, and then 64. And you can go as far as you need to go, but I don't need to go this far because my decimal number is 22. So really what I do is I try to figure out which is the first number that falls into 22, and that's of course a 16, right? So I can put a 1 in the 16 spot. What's in the 64 spot? Well, there's zeros. They're all zeros all the way out here. So really I can start with the 16 spot. I can put a 1 in there. And then if I take 16 from 22, what do I have left? I have 6 left, right? So can an 8 fit into 6? No. So I have 0 8s. How many 4s would I have? Well, I'd have 1 4. And I could put a 4 there and subtract that, and now that leaves me with a 2. So what can I put in the 2 spot? I can put a 1. Now how much do I have left over? I have 0. So do I need another 1? No, I do not. So that is the number for 22. And you can write it 1 0 1 1 0. You can write it like this. Or a lot of times what we do is we like to try to fill out a whole byte. So you would put in 3 zeros here in front. And that's a whole byte of information. That'd be the number 22. Yeah. So really you start with your decimal number and you figure out what's the first place value that can fit into that and turn that one on. Subtract it and see what the next place value that can fit into that. And if one can't fit into it, you put zeros or the remainder is 0. And that's how you do binary. So we're going to talk about some other numbering systems too, and then kind of talk about how some of this goes together. So hopefully the binary system made sense to you.